Good evening. From today's session, we are starting with unit number 7, that is arrays and strings. So before this, I want to ask you that the recorded videos that I had sent based on functions and pointers, have you gone through them?
One, two videos are remaining.
Okay. Have you understood functions?
Yes.
Okay. So pointers, another few concepts are remaining. That video also I'll send shortly. And others who have not seen also can see it now since you're free. So from today, they're part of data structures. That is one of the important subjects in your second year of engineering. You will have it, data structures. There are different kinds of data structures. Out of that, the basic type, which is usually used, is arrays. So first we'll go through what are the different types of data structures, means what are the names and what are their characteristics, and just in brief, what is the classification. Then what is sequential organization, array, which is an abstract data type, then how to represent an array in memory, how to calculate the particular address. Now there is close relationship between pointers and arrays that we'll be seeing later on. Then the types of arrays, there can be single dimensional or multi-dimensional. Then certain operations on arrays you can perform, like merging arrays, inserting an element into an array, or deleting an element, how to sort or arrange an array, how to update the values which you have stored in the array. And then certain types of matrices. Now matrices can be displayed using two-dimensional arrays. And after that, strings we will see. So for today, we'll go through the basics of data structures and then the remaining. So I'm starting the presentation. So as I said, we are going to see the classification of the data types and data structures. So firstly, there are two types of data structures. That is, they may be primitive or non-primitive. Now there is some difference between data type and data structure. The data types that we have seen till now are integer, float, character, boolean. So these are just the basic data types. They can store a particular single value, right? You can store in integer what you can store. Suppose you want to store the number 5. In float, you can store 4.6. Logical or boolean is same. We can call boolean as logical. You can store either 1 or 0, that is true or false. In character, you can store a single character like A or any character. So these are the primitive or the basic data types. Now, other than these, you can have different types of data types. I'll show you an example here. See here, we have seen this in our second session, the different types of data types. So we have seen which ones? We have seen the primitive data types, right? Here I had written primitive when I was explaining. Now we are going to see the derived data type in the middle, this block. Derived data type means first type is array. Means you have to derive the data type, and this data type is called array. You have to derive the derived data type from the primitive data type. Array is derived from primitive data type. Okay, then you have user defined data types also, which we'll be seeing in our next unit. So non-primitive data type means the ones which need to be derived from primitive data type. Now, in non-primitive data type, you can have homogeneous as well as heterogeneous data. Now, difference between homogeneous and heterogeneous is, in homogeneous, you have the data which is of the same type. Means suppose you have 5 integer values, they are all of the type integer. So they are homogeneous data set. But if you have one integer, one character, one float, or two integers and one float, so if you have a combination of data types, then it is of the type of heterogeneous data. So these are the classification under non-primitive. Now you might have heard about list in Python. You have recently given your exam, so I'm sure you know about list in Python. So in list, can you store homogeneous data or heterogeneous data? Can you tell me?
Both.
Heterogeneous.
Yeah, yes, both also is correct answer. Means either all the elements are of the same type, all are integers or all are characters, or a mixture of the data types. Yeah. Now, so in non-primitive, you have further classification, that is linear and non-linear. So array is a linear data type. Linear means the elements in an array are arranged in a particular fashion or particular sequence such that you have one element, after that you have another element, then before that element you have some element. So there's a linear ordering over here, means one after the other you can store the elements. So what you can say in functions, in mathematics you have studied functions, so one-to-one mapping is there, means for every value you can have some previous and some next value. So there is a unique predecessor and a unique successor. Means suppose you have three values, 3, 4 and 5. So the predecessor, that is what comes before. The predecessor of 4 is 3 and the successor of 4, that is what comes after 4, is 5. So linearly you can store the elements like this. You will be able to understand this better because you have already studied list in Python. Now other type is examples of linear is array, linked list, stack and queue. Okay, and there are difference between these data structures also, which we'll be covering later on. Next type is non-linear, means here there is no linear ordering. It is not that you have one after the other. You can have a hierarchy. Suppose you consider a tree diagram. So suppose here you have the letter A, then you can have some subcategories like B, C and D. So after A, what you have? You have B, C, and D. So there is no linearity mentioned over here. Means more than one successor is possible. And before A also, maybe you have only a single element X. So you can have one or more successor and predecessor. And there is no linear, means it can be linear, but it is not compulsory. That I want to say. Means you can have after A, you can have B, then you can have C. This is okay. But you can have like this in between also some elements. So linear order can be implemented, but it is not compulsory. You may have many to one operation, many to many operations, or one to many operations. One to many example is to A, you are mapping B, you can map C, you can map D. So one to many to many would be suppose A and X are mapped to B. So you can have different operations over here. We'll see that in other units. Example of nonlinear is tree, graph, and table. Tree, just now I gave you an example. Graph, it is a set of vertices and edges. Okay, it is not the graph that you draw on a graph paper, but it is a little different. And tables are another concept. Table is like a two-dimensional array, but it is a little different because it is coming under non-linear. Array is linear. Have you understood this classification of data types and structures?
Yes.
Yes.
Okay, yeah. So now I've also told difference between data type and data structure. Now, why do we need data structures? See, suppose we want to store a large number of elements. Okay, in integer variable, you can store a single value. Suppose you want to store 10 values, then 10 separate variables of integer type you can use. But what if you want to use to store 100 variables? Then it is not efficient to write 100 variables. So what you can do, under the same name, you can list out the variables or you can list out the values that you want to store. Means suppose I have an array with the name A. Within my array, I can store a number of elements. Suppose I want to store 1, 22. Okay. I don't have to write A is equal to 1, B is equal to 22. I can, in a single name, I can store a number of values. Okay. This is the advantage of the data structures because a number of values can be organized in a particular pattern or a fashion or a particular order. And what is the advantage is that accessing these elements will become efficient and easy. If your data elements or data items are arranged in a specific order, then they can be accessed in a particular way. And depending on the order, you can access it in different ways. In non-linear data structure, you can access from one element, you can access other elements. In linear, you can access them even directly. So we'll see how to access the elements, how to print the elements and all. But the main idea is to efficiently manage your memory, you can use the data structures. So we can define data structure as it is a collection of the data elements or the data items and all the possible operations that can be performed on those data elements. Okay, and examples I've shown you: array, linked list, stack, queue, tree, graph, table. And you can represent a data structure with the help of a domain of input values, a domain of functions and axioms. Means whatever you can perform on the elements, that also is defined by the data structure. Depending on the type of data structure that you are using, you can perform different and unique operations. Okay, now we will start with arrays. So firstly, this is the definition of array: that an array is a linear data structure, we have seen the classification, which stores finite number of elements in successive or consecutive memory locations. Now, consecutive memory location means I've already told you that the elements are stored in memory and you can access them from the memory. So even variables, they are stored in memory at a particular memory location, and that memory location has certain address. Using that address, you can find that memory location, and in that memory location, your data is stored. So in successive or consecutive memory locations means you can consider a block like this, and in that there are some divisions. Okay, so this is one memory element, y is another memory block, z is another, w is another. So these are the consecutive memory blocks or memory locations. So in this consecutive order, means one after the other in the memory. Okay, I'm not talking in the data structure. In the memory, one after the other you can store the elements. It is not that you will have some gap over here and then you can store another element. Okay, consecutively each gap or each block should be occupied by the data elements in arrays. Have you understood this?
Yes.
Yes.
Yeah. So for example, array may contain all integers or all characters, but not both. So each array can be accessed using an index. Now how can you access the data elements? Since you are storing them under the same name, they can be accessed using that name, but using an index. It must be a positive integer value enclosed in square brackets. Even in list, suppose you are using in Python, then you can write a of 4, suppose. Okay. Similarly, in arrays also same syntax: a of 0, a of 1. You can access the elements in this way, but square brackets. Okay. And the index always starts from which number? Can you tell me?
0.
0.
Yes, it starts from
Zero.
0. Yeah. Starts from 0 and goes up to n minus 1. Suppose you want to store 4 elements in an array or in a list, then it goes from 0, 1, 2, 3. Okay, these are the index values which are satisfying the data structure. These are the acceptable values of the index. You cannot have 4 because index is starting from 0. So whatever your size of arrays or whatever the length of your arrays, suppose it is 4, then your index is from 0 to 3. That means index is from 0 to n minus 1, where n is equal to 4, then it will be up to 3. Okay. For example, array of n, then it goes from array of 0, array of 1 up to array of n minus 1, where 0 is called as lower bound. It is the starting address of your array. The address of the first element in an array is known as starting address of the array. And n minus 1 is the higher bound. So we have different types of arrays like single dimensional or one dimensional, and you can have two dimensional or multi-dimensional. So we'll see for now what is one dimensional array. And before that, see here, I'll show you what are consecutive memory locations. This slide I've included even in pointers. See, suppose you have a block of memory. It starts at the address 1000. Then next location has the address 1001. Next location has the address 1002, and so on up to 19. So here there are 20 blocks, okay? Because it is starting from 0, that is 1000, it can go up to 19. So total there are 20 blocks. Now, this is the first block at address 1000. Now each block is of 8 bits. 8 bits is how many bytes? Can you tell me?
64.
No, 8 bits is 1 byte, no?
हाँ 1 byte.
Yeah. So each block that you can see here is of 1 byte, that is 8 bits. So 2 blocks is of 16 bits. 3 blocks will be of 30, 16 plus 8. And then you can have 32 blocks, 32 bits ka blocks and all. So what I want to show you that if you have an integer occupies 4 bytes in memory. Okay, it may occupy 2 bytes also. Suppose you consider 4 bytes, then each block is of 8 bits. So 4 bytes means 8 fours are 32 bits. So you have to consider 4 blocks. So each block is of 8 bits, or it is of 1 byte. Since you want to store your number, which is an integer, any integer value will occupy 4 blocks to get stored in memory. Okay, it is not just one block, you have to use 4 blocks, because each integer value, suppose the value of the integer is 4, then 4 blocks. Even if the value of integer is 100, then also 4 blocks, because every integer value will occupy 4 blocks in memory. Have you understood this?
No.
Yes.
Okay, I'll repeat. Each memory block is of 8 bits, that is 1 byte. And integer occupies how many bytes in memory? 4 bytes. So this is 1 byte. Since this block is of 1 byte, you have to access 4 blocks so that you can access 4 bytes. And each integer value will be stored in a group of 4 blocks. So each integer occupies 4 bytes, so 4 blocks. So now let us consider, suppose you are using the compiler which supports integer which occupies 2 bytes. So suppose you have an integer I which has the value 2. Then suppose it is allocated memory or assigned memory at this location. Then these 2 blocks will be considered now, because I'm saying that integer occupies 2 bytes. Then this is of 1 byte, and the second block is also 1 byte. So 2 bytes, you can store the variable I over here. Okay, have you understood this much?
Yes.
Yeah. So these were the consecutive memory locations, one after the other. In this way, the elements will be stored. So if I want to store uh, 2 integers, suppose I have an array with the name A, and its size you must mention in square brackets. In C, C++, you have to specify the size. Okay, we'll see how, why and how. So suppose my array holds the elements 3 and 4. So these are 2 integers which I'm storing. So the size of my array is 2, or the length you can say is 2. So for one integer, suppose it occupies 2 bytes, for one integer will occupy 2 bytes. Then I can store the number 3 over here and the number 4 over here. So 3 is stored, and then immediately 4 is stored. Okay, so in consecutive memory blocks, continuously one after the other, we are storing the elements. Now, the syntax of declaring an array. A one-dimensional array is also called as linear array. So you can think of a linear array as a single row or a single column. So you have to first specify the data type. Suppose your array is of integer type, then data type is int. Then you have to specify the name of the array and then the size of the array. Okay. In Python, you are not specifying the number of elements that you want to store in your list. But in arrays, C, C++ arrays, and even Java, you must specify the size. So see here an example. You have the elements here 40, 55, 63, and so on up to 89. So these have to be stored in an array. So the length of the array in this case is 9, because I'm storing 9 elements. And index will go from where to where? Starting from 0 and 1 less than the total number, that is 8. So if here n is equal to 9, so my array index is maximum up to n minus 1. And what is the first index? 0, last index 8. Another example, when you want to initialize your array, same thing, data type you must, and here uh, you must, it is better to initialize at this in the same line of code. You can do it in the next line also, but it is recommended but in the same line. So first data type, then the name of the array, and then the size, then use assignment operator, and then whatever values or data you want to store in your array, that you must specify in the curly brackets. In Python, for list, which brackets you are using, can you tell me?
Square.
Yes, you are
Square.
using square. Yeah, very correct. In C, C++, Java, curly brackets. So, example, int is the data type. So, in the array, I can store only integers. Name of the array is ARR. Okay, when we are studying arrays, usually we name it as ARR. You can name it anything what you want. And what is the size? Means how many elements you want to store in array. Suppose you want to store 6. That you must mention in square brackets, equal to or assignment operator. And within curly brackets, 6 elements you can specify. So these are the values that you're specifying, name of the array and all. So whenever you want to use array, what all data, what all information you must have? You must have the information that which type of elements I want to store. That is the data type you must know. Then you must know what is the name of the array. Otherwise, you won't be able to access the elements in the array. You must know which name, what is the name of the array. Then you must also specify the size of the array, and then you can initialize it. You can either initialize it in your program, or you can accept the values from the user also using Scanf. We will see that also. So how can you refer or access a particular element? The element which is stored at the first position is known as a of 0, means array name of 0. The next is a of 1, then you have a of 2, a of 3, and so on. So when I write a of 0, I can access the first element. What is the first element in this case? It is 2. So I can access 2 using a of 0. If I use a of 1, then I can access 4. Similarly, if I use a of 5, I can access 8. Okay, because index goes from 0 to 5 because I'm storing 6 elements. So a of 5 will give me 8. And these are the address. Now see, integer here, it is occupying 2 bytes. Okay, so the address is 100. If I do plus 1 to the address, it is 101. But integer will occupy 2 bytes. So again, I have to do plus 1, address is 102. Means first element is stored in at 100, and the next element will be stored at 102, plus 2 bytes at 104, next element, plus 2 bytes, that is 106. So address will be incremented by 2 each time, because at one address, you have 8 bits. See here, at a single address, how many bits you can store? 8 bits. Okay, but 8 bits, that is 1 byte. And you want to store 2 bytes because integer occupies 2 bytes. So at 1000, the lower part of the integer will be stored, and at 1001, the higher part will be stored. Okay, means first 8 bits here, next 8 bits here. So after this is what at 1000, what you can find? You can find a of 0 at 1000. If you want to find a of 1, it will be at 1002. Okay, have you understood this?
Yes.
Yes.
Yeah. Okay, so address, how it is incrementing by 2 each time, because integer will occupy those many memory locations. So plus 2 you have to do to each address. Now, what is base address of an array? It is the address of the first element of the array. See, first in the memory, what will be stored? A of 0 will be stored. Then plus 2 due to the address, what will be stored? A of 1. Plus 2 due to the address, what will store? A of 2. So first element which is stored, A of 0, and the address of A of 0 is known as the address of the complete array. Address of the array is nothing but the starting address of the array. And starting address of array is also known as base address of the array. So using the address of the first element, you can calculate address of the next element also. We'll see an example now. You may, in second year, you have the question that calculate the address of the nth element of an array. So here you can, since you're attending this session, you already know. So that's why all who are in the group, in our WhatsApp group, they should attend these sessions because it will help you. You're, you're practicing before your second year can start. Here need not to keep a track of the address of the data elements. Why? Because using the address of the array, you can calculate the address of any element in that array. So we can track the memory location also using the address and using the base address. Now to calculate memory location, Now this is a bit complicated formula. The formula that usually should be used, or which is an easier formula, is this one. See here at the bottom of the slide. This is the alternative formula. What is the formula? Location of any element a of I is equal to base address of the array plus the index of the element which you want to access. If you want to access a of I, then the index of a of I is what? I. So that index you must specify and multiply it with element size. Element size is nothing but the size of the data type of the array. If array stores integers, then data type of array is int, and int occupies 4 bytes or sometimes 2 bytes. So that is the element size. Each element in the array occupies, what is the size of each element in the array? It is 2 bytes. So that is element size. So using this, let us solve the above example. We'll first see the simpler formula. See, we can find the location of element 5 present at a of 3. In the example here, see 5 is present at, suppose if it is at a of 3, okay? Don't consider that example. Suppose an element 5 is at a of 3. You have an array of size 4, and in that you can store 4 elements. So first, suppose you're storing 3, then you're storing 4, then you're storing 6, then you can store 5. So what will be the element at a of 3? Can you tell me?
5.
5.
Yes, 5 is at a of 3. So what is the index of 5? It is 3. So we got to know that the value of index, that is I, is equal to 3. And now suppose the base address, it is already given in the question. I'll just erase the other ink over here. So base address is 100. So the address of array is 100, and the address of a of 0, that is the element 3, is stored at a of 0. Address of 3 is also 100. So now we have to calculate address of element 5. So in the formula, how we have to substitute? Base address we already know is 100 plus, what is the index of 5? It is 3, and into, suppose integer is occupying 2 bytes, then into 2. So multiplication you have to do first. 3 2s are 6 plus 100. 106 is the address of element 5. Okay, so using the second formula which I have written, you're getting the same answer, and first formula is the same answer. The only difference is, in C, C++, Java, Python, your arrays or list starts at the index 0. Okay, it cannot start from any other index. But there are some languages in which index starts from 1. So if the array starts from 0, it is called as 0-based indexing. If it starts from 1, it is called 1-based indexing. If it starts from any other number like 2, it is called 2-based indexing. So we are following 0-based indexing, so we can use the second formula. If we were using the 1-based indexing, means if index had started from 1, then the formula is, see at the bottom of the slide, base address plus w k minus lower bound. So if we use this formula, base address you can substitute as 100, okay, 100 plus element size, okay, the w what I had written, that is element size, that is 2, into the uh, element ka index, that is here 5 ka index is 3, that minus the starting index. Okay, I'll write it here. It is also equal to base address plus the size into the index which you are interested in, the element which you want to find, that ka index, minus the starting index. Okay, have you understood the other formula also?
Yes.
Yeah. So
How
better,
100 came?
100 is given in the question, that is base address, that is starting address of the array.
Okay.
Okay. Yeah, because in the memory where the address is, we cannot know directly. No, it is not that if there are 3 elements, they'll be stored from 100 only. That is not the case. Wherever there is space in your computer memory, there the memory will be given to your array. So it is not like always it will start from 100. So in the question, it will be given to you, the address. Have you understood?
Yes.
Yeah. So from base address, you can calculate the address of any other element. If they ask you the address of the element a of 0, so base address is 100. What is the index here? If you're finding for a of 0, what is the I value here?
0.
Yeah, correct. It is 0 into element size 2. So 0 into anything is 0. So 100 plus 0 is 0. That is 100 plus 0 is 100. That is 100 is the base address. That is starting element ka address. Now there are different ways in which you can declare your arrays in C language. So I'll show you quickly. See here at the left side, int a of 3. This is declaration. You have not initialized your array. So in this case, all the values that will be stored in the memory will be garbage values because you have not initialized your array. So only memory is allocated or given to your array, but there are no values stored at that memory. So whatever the garbage value, any value will be available in those locations. Have you understood this? When you declare, what happens? Have you understood?
How
Yes.
garbage value will be there?
Because you have not initialized your array, no? Whatever previous, see, once you write any program, you will store some value at some address. Then when you exit from the program, either that those values will get cleared from that location, or they may be there in that location itself. So next
Yes.
time, whenever you uh, write any different program, that location which was not accessible, since the previous program you have terminated, you have finished, so those locations are deallocated, but the value can be stored there, or it is empty, or it is erased. Any value can be stored there. So when you write a new program and you want to allocate memory for a new array, those same memory locations can be used. See, it is not that only once you can use that memory location. Otherwise, your computer memory will not be sufficient, right? You write so many programs. For each program, you can't have separate memory. You have to reuse the memory. So whatever previous value was there, that is available. And previous value can be any value. It is not that only from your previous program. It can be by default value also. So the garbage value is there when you declare. Have you understood?
Yes. And can we use clear screen CLRS here in
Yeah,
C?
that is only in C. Yeah, you can use. That is not supported by Dev C++, but by in Turbo C you can use it, and that is just used to clear whatever output you have received at your screen.
Yes.
So that is not for clearing memory, but at the output, if you don't want something, you can clear your output screen. Okay. Now next way you can declare your array is by same time you can initialize it also. So A of 3, that is you can store 3 elements, and suppose you are storing the elements 1, 2, and 3. So in the memory, 1 will be stored, then 2, and then 3. Now same example, but I'm storing the same elements. I'm storing 1, 1, 1. Okay. So now if I'm storing 1, 1, 1, I can store 3 elements. So 1, 1, and 1 will be in memory. And it is not that you cannot store duplicate values. You can have duplicate values also in your array. Now, suppose you do this type of initialization. See in this side, this one, int a of 3 is equal to curly braces, but inside the curly braces, you have not written any value. Okay, this is different, and this declaration part is different. Okay, first case that we saw, case 1, is only declaration, but this is case 3, in which you are initializing to empty values. Means you're not giving the values, but you have initialized it. Okay, this is valid. In this case, what happens, in each location the default value will be stored. What is the default value? It is 0. So in each location, since you can store 3 elements but you have not stored them, so in 3 locations you can have the value 0, 0, 0. So now if you try to access any element, you will always be able to access the value 0. Have you understood the difference? Yes or no?
Yes.
Everyone?
No,
Yes.
repeat once.
See, I'll repeat. See, if you only declare your array, then garbage values are present in the memory. But you have initialized it. This is initialization. This will not give you any error if you don't write anything in curly braces. Okay, and by default, the values 0 are stored. And if you want to access any element, I'll show you in a program also. If you'll believe me then. See here, I'll show you. See, this is an example in which I'm initializing that same array, A of 3. I can store how many elements here? I can store 3 elements. Can store 3 elements. I'm not giving anything inside my curly brackets. And now, for now, don't look at this for loop. If I write printf, and now data type of array is integer, so I can use %d. And then I have to mention the name of the array. And then suppose I want to access a of 0. So a of 0 should be the element 0. So let me run this program. See here, you're getting the value 0. Okay. So in memory, you have initialized, but you have not given the values. So default value is 0. Now suppose I only declare my array. Okay. I'm not giving the empty curly braces. And now if I try to access a of 0, let's see what I get. In this case, you're getting 0. Okay. Because I've shown it in the same program. So memory is I already 0 over there. Isn't it? Because I've changed the value just see before what I've done. In the same program, I had empty curly braces. So in that location, 0 was stored. So that was the previous value. Now I've removed it. I've only declared. So the garbage value there is the previous value, which is 0. Okay. If I try to open, or let me write a new program now. Let me save, include the header file, void main. Here I write int, suppose b I take this time, b of 3. I have declared my array. And if I want to print using %d, b of 0 or b of 1, whatever. And now when I execute, first let me save my program. See here, what value you are getting? 101. Okay, this is the garbage value in this location. Okay, have you understood? You may get garbage value or the previous value. Okay, if you write a different program, you'll get some other garbage value. Have you understood this?
Yes.
Yes.
Okay, yeah. Now, so that's what garbage value means. Whatever previous value was stored in that location, that you will be able to access. That is why after changing it to declaration part, that 0 I was able to access. But it is not the case always. If you change your program, the garbage value may be something else also. If I try to access b of 2, let us see what we get. See here, any value you may get. You may get 101 this time, next time some other value. Okay. Now coming back to the slides. So we have seen case 3. Next is suppose you write, see here, this is a combination of all the cases that we have seen till now. What is the second case under case 3? If you write a of 3 is equal to, you write only one element in your curly braces. But what is the capacity? You can store 3 elements, but you are storing only one element. So this 0 that I've written here will be stored at a of 0. Okay, and remaining 2 elements are missing. So by default, since you have initialized the default value, 0 will be available in those positions. Okay, see in case 1, what is the difference? Only declaration, garbage values. Then case 3, first case, what was it was? If you initialize without specifying the values, default values are 0. If you initialize without specifying all the values, you can store 3 elements, but you're storing a single element. Then that element will be stored at first position and remaining values are 0. See the next case under case 3, you're storing only a single element 1. So a of 0 is equal to 1 and the remaining values are by default 0. Have you understood? Have you got the point?
Yes.
Yeah, let us see the program also so that you remember this. See here, same thing I'm doing. I'm storing the element 5 over here. I'm storing a single element. Okay, now if I access a of, sorry, b of 0, I should get 5. See, I'm getting 5. Now let me access b of 1. I should get 0.
0.
Yeah, see, I'm getting 0. Okay. So you can test in this way, whatever you're learning. Okay. Now, next is case 4. Now, this case 4 that I'm talking about, it is not supported by the compilers nowadays. Okay. With the compiler GCC 6 point something, that compiler onwards, whatever versions were there, they are not supporting this type. So here, I think you can guess what is this. This is the slicing operation in Python, right? You can write 0 colon something to access a range of indices values. So somewhat that was supported earlier, but this is not possible now. So I don't want to like introduce this to you because you may get confused. So only what cases are valid? Case 1 to case 3 are valid. Okay, have you understood till this much? How in different ways you can declare and initialize? Have you understood?
Yes.
Yeah.
Yes.
Okay. Now, before going to two-dimensional arrays, let me show you different programs. Okay, because programming is definitely important. Whatever theory you've studied, we'll implement now. See here, the data type of array is float. So I can store floating point values. You can store 3.1, or after the decimal, you can store how many ever digits you want. But how precise the value will be stored in memory, that is different. Do you know that I had shown you using the program difference between float and double? Do you remember?
Yes.
Yeah, so I hope you remember. So they were the precision, how precise the values are, that is different. Okay, so you can revise it later on. Now you can store the values. How many values? 4 you can store. We'll also see if, see, now the size is 4, but if you store the elements 5, 6 or greater than 4, what happens? If you store lesser elements, what happens? That also we will see. For now, you are storing the exact number of elements. Now, if I now also remember the different format specifiers. If you want to specify an address, okay, you can access the address at which the memory location in that the data is stored. That address you can access. You can print the address in your program. It is possible. So how you can do it? Using the format specifier %p. %p is used for what? For displaying addresses. Similarly, %d is for displaying integer values. %f for float values. So %p for addresses. Remember this. So whenever you want to display the address of an array, what will be the address of array? It will be the base address. What is base address? Starting address. Starting address means the first element ka address. What is the first element? This one. So the location in memory at which 3.176 is stored. The address of that memory location is the address of the array, and that you will be able to display here. So let me comment out the remaining printf and show you this much execution. So see here, and addresses are always in hexadecimal format. That is why in the address you can see the letters also. F stands for 15, E for 14, right? You know that. You have studied number systems in basic electronics engineering. So you can have hexadecimal addresses. It is an efficient way to represent the address. So by just writing array name, you can access the address of the array. See the next case. If you want to access the address of the first element, okay, I'm not saying the address of the array, I'm saying address of first element. But what will be the address? It will be the same as the address of the array. Okay, address of array or address of first element, it is the same. So for address, see in scanf we were using, see what is the syntax of scanf? Scanf %d, give a comma outside quotation, and ampersand whatever variable name. Okay, so ampersand n means what? Whatever value the user enters, it will be stored at the memory location which is allocated to the variable n. Okay, means using ampersand or your address of operator, we can access the address of a particular element or variable or any entity. So whenever I write ampersand variable name, it means I'm accessing the address of the memory location at which the variable is stored in memory. Have you understood this?
Yes.
Yeah, and this is not your bitwise AND, it is not your logical AND. That is AND operation. This is AND for address accessing. So when I write address of A of 0, I can access address of the first element. And see, as I had mentioned, address of array and address of first element is same. So you can see here at the output, I'm getting the same address. first printf statement and second printf statement is giving me the same address. Okay. If you write array name, you get address of array. If you write ampersand element of array, you'll get the address of the element. Suppose I want to access address of a of 1. Okay. A of 1 will be 4.2 and address of 4.2 I'm accessing. Let me print it out. See here, address of array is 90. Address of first element is 90, but address of first element at 0 index is also 90, and but the address of the element at index 1, that is 4.2, is 94. And by this we have one more conclusion, that the address is incremented by 4. Why? Because float also occupies 4 bytes in memory. Data type of array is float, 4 bytes, so each value in the array will also occupy 4 bytes. Okay, so since it is occupying 4 bytes, so a of 0 will be stored at fe90. Let me show you again so that you have a better understanding. See, at this address, a of 0 will be stored. Then you'll occupy or consume 4 locations. Okay, suppose it is float, and then at the address 1004, the a of 1 will be stored. Do you agree with me?
Yes.
Yes.
Yeah. And after, for this a of 1 also you will need 4 memory blocks. So 1004, 1005, 1006, 1007. At 1008, which element will be stored? A of what?
2.
Yes. Then again do plus for the next element. So this way you are getting the addresses. So if it was starting at 1000, the address of a of 1 will be 1004. Similarly, in our program, our memory is allocated at hexadecimal address 1009, fe90, plus 4, you'll get 94. Okay, and fe means what? Consecutively we are increasing. It is not that by accident we are getting plus 4. Okay, now next, if you do a of, if you want to print the value of first element, then a of 0 is sufficient. You will get the value what? 3.176. Now for next case is if I write asterisk of a. Now remember, if you write only array name, you get the address of array. If you write asterisk a, this is actually the concept of pointers. So you need to see the previous video that I sent last night. Whenever you write address of something, you'll get the address of its memory location. Whenever you write asterisk, then whatever value is stored in that memory location, that you can access. So if I'm writing a, I can access the address. If I write asterisk of a, then whatever value is stored at that address, that will get displayed. Have you got it?
Yes.
Yeah. So if I write a, I'm getting address of array. Now a and a of 0, it is the in the values. Okay, so let me execute first and show you, understand better. See here, I've executed 4 printf statements. First printf statement, I've got address, then again address, and a of 0, I've got that value. Okay, I've got the value of a of 0 with 6 points after decimal. That is by default. And if I write star of a, now star of a or asterisk of a means I'm referring to the first element. Whenever you want to see address of a is something, suppose the address of a and address of a of 0 is the same. Similarly, when I write I want to access the value, if I write a of 0 or if I write asterisk of a, it means a of 0 ka value only. Have you understood? That's why you're getting 3.176 only. Okay, have you got it?
Yes.
Yes.
Yeah, so we'll see some more examples, just 1 minute. See here, I'm writing again a of 0. Now I can write a plus 0 and then give asterisk. Means I'm doing plus by how many times? 0 times. So it is the same as writing only a, right? Here I've written only a, and here if I write a plus 0, it is the same thing. Okay, so same value you'll get. Let me run it. See here, for all the statements I've got the a of 0 ka value. Now, see the next trend. If I write a plus 1, what do you think? Which element will get accessed?
First element, second.
Yeah. So the
4.2.
element, okay, so actually it is by a you can access first element. By a plus 0 also you can access first element. But a plus 1, you can access the second element. That is at index 1. So at index 2, if you want to access, you will have to do a plus 2. If at index 3, then a plus 3. So can I say it is a plus index value, isn't it? If you want to access 0, then a plus 0. If you want to access the element at 1, then a plus 1. So I am saying it is a plus index. Did you understand?
Yes.
Yeah.
Yes.
And if I write a plus 1 only, okay, see the line number 19. I'm writing only a plus 1. Let me execute and see what happens. See here, I have not stored, this is the output of the last printf statement, and I have not stored this number, okay? So what is happening? It is some garbage value. Okay, it is not giving me the correct thing. So what I should do? I should write asterisk to access the value. In pointers, I've nicely explained this concept, so you're getting the correct value. So what you refer that video, and also remember that whenever I write ampersand, I can access the address of that element. Whenever I write asterisk, I can access the value at that. Now I have written asterisk of a plus 1. It will give me the same effect if I write a of 1. Do you agree?
Yes.
Yeah. So both the ways will give you same. Let us see if I'm getting 4.2. Yes. Last two printf statements are giving 4.2. Have you understood this program?
Yes.
Yes.
Yeah. Now another way to access elements. See here, I have declared my array. And as I said, you can initialize it later on also, not necessary on the same line, but it is better or it improves the code readability if you do it on the same line. Declaration, now I'm initializing a of 0, array of 0, arr of 0 to 5. So arr of 0, or let me say a of 0 is 5. A of 2 I'm initializing now. Okay, it is not necessary after a of 0, you must initialize a of 1. You can initialize a of 3 or directly a of 7 also you can do. So whatever locations you have skipped, at that what you'll find, you can find 0. So now a of 0 is 5, then a of 2 is minus 10. Okay, 5 and minus 10 both are integers. You can store it. Next, if I write 3 divided by 2, so 3 is an integer, 2 is an integer. So the result of division, that is the quotient you can access, it is also an integer. What is the value? 3 divided by 2 is 1.5. Integer part you have to access, that is, you have to neglect the decimal part, that is 1 you can access. So indirectly, this is ARR of 1. So you can have such expressions also in place of index. Okay, but it should be a valid index at the end. So I can access 1 here. So I'm initializing a of 0, then a of 2, and then a of 1. And this is giving me the value 2. I'm storing 2 in that location. Then what I'm doing, see here, you can assign previous value also. ARR of 3. In that I'm storing the value of a of 0, ARR of 0. Okay, so ARR of 0 is 5, and that I'm storing at index 3 also. It is possible. And here I'm printing one by one, a of 0, a of 1, a of 2, a of 3. Let us see. See here, at a of 0 you have 5, at a of 1 what you have 2, then at a of 1 you have 2, a of 2 you have minus 10, and at a of 3 you have a of 0. A of 0 is 5, a of 3 is also 5, because that is how we have stored. Have you understood this program also?
Yes.
Yes.
Okay, very good. So these are the basics of arrays, and here, as I had mentioned, you have initialized, but you have not specified all the values. See, I've commented out ARR of 2. So what I'm storing? I'm storing at index 0, at index 1, at index 3. But I'm not storing anything at index 2. So by default, what should be present there? Can you tell me?
Previous
Zero.
value.
0.
It is 0. Previous value is in the case only when you declare and you forget to initialize. Okay, see, I'll show you.
Yes, 0 will come.
Yeah, so 0. So, but still I'll show you just so that you remember it. I've not see all these initializations I've commented. So I've only declared, let me see. See here, you're getting any value. Okay, it may be garbage or it may be previous value. But here I am initializing. Maybe not all the state initializations, but some initialize. Even if one initialization you have done, the remaining will be 0. Even if you initialize all, that's also good. Okay, so you have understood this also. Now next, now instead of doing in this way, like I'm initializing separately and I'm printing also separately, means I'm printing a of 0, then a of 1, a of 2. I can use a for loop also, isn't it? In a looping statement, I can access all the values. Even for list, you can iterate through it, right? Similarly, you can iterate through an array. For example, see here, a of 5, it's a little difficult to say ARR every time. So I'm saying a of 5. So I can store 5 elements. I have stored it. And now let me remove this statement. I'm using for loop. What is the syntax? Initialization, condition checking, then increment, decrement. So I have to start at index 0. Why? Can you tell me why I have to start at index 0?
Because array of index is 0.
Yes, very correct. Excellent. It starts from 0. Then I have to I can have the possible index. Which one? 0, 1, 2, 3, 4. So my I value is always less than 5. And 5 is what? Size of my array. So size minus 1, up to there my index is defined. Have you understood?
Yes.
Yes.
Yeah. And I plus plus. So, and what I'm doing in my printf, and since single statement is there, I don't need curly braces around for. What I'm printing for ARR of %d, the value is %d and address is %p. For address, %p format specified. So how it will get printed? In place of this %d, I'm printing I. So a of I value is a of I. Okay, this a of I will come here, and address is ampersand of a of I. Okay, if I consider for element 0, then how it will be? For a of 0, value is a of 0 and address is ampersand a of 0. Okay, but here we are going again and again in loop, so you have to use the counter variable I. So let me execute this program. See here, for a of 0, value is 10, address is this. For a of 1, it is so and so and so. And here also addresses you can see here, consider 8. And since it is integer plus 4, my compiler has plus 4 for the size. Plus 4, what you'll get? 12. But address is hexadecimal. 12, how you can represent? Using the letter C. So that is why you're getting C over here. Okay, after 88, you'll get 8C. Then C is 12 plus 4, what you get? 16. 16 in hexadecimal is 10. So you're getting 90. Okay, I've explained this in my pointers video also. There also you can go and check. Okay, so only I'm going a little quickly. Okay, so this is how using for loop. You don't have to access each time a of 0, a of 1. Have you understood this program also?
Yes.
Yes.
Yeah. Okay, remaining concepts we can see next time. If you have any doubts, you can ask me and quickly put your attendance in the chat section, chat box.
How we can declare heterogeneous array?
In C, C++, Java, it is not possible. There is no way by which you can declare heterogeneous arrays in C, C++, Java. It is supported by other languages like Python, R programming language, and different languages are there, those languages. And one more thing, even in Python, you have list, but in Python, you have a special library called as NumPy. Have you heard of it?
Yes.
Yeah, in NumPy library, you can have arrays in Python, okay? But usually we use list. Yeah, any other doubts?
And the next session will be from Wednesday, Friday, or Tuesday, Thursday
Actually, I
pattern
was thinking we'll, since now, can you tell me when is your second year lecture starting?
from Monday.
17.
Okay, even
Second.
us. Actually, you know what? This time, what has happened? The first year, that is, you are in first year, I am in second year. Between both of us, there's only a gap of one semester. You have finished giving FE exams of both the semesters, but second year, third year, final year have finished giving exams only for one semester. So between us, there's a gap of only one semester. So the teachers who are teaching me will be teaching you also. So that is a very uh, means it has happened this time this way. So I was thinking that I'll send recorded videos also, and next we'll meet. Today's Wednesday. On Friday, we'll try to meet. Okay. So I'll be sending recorded lectures also in between so that we can finish fast because I had to wind this up in your first year itself, but now we are going to second year already. So recorded videos also I'll send and we'll meet also on Friday now. Okay.
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 Yeah. Any other doubts? If not, you can leave the meeting.
So will there be any pattern or randomly it will be
Which for what pattern?
sessions?
Yeah, for till 17th, we'll meet on Friday. I'll send on the WhatsApp group one day earlier. Don't worry.
Okay.
Yeah. Any other doubt?
Thank you.
Yeah, welcome.
Yeah, thank you.
Thank you.
Welcome, welcome,
Thank you. Thank you, Dada.
welcome. Yeah. Any doubts remaining?
Okay. Thank you. Bye. Bye.
Yeah, bye bye. Welcome. Do you have any doubt, Kiran?